Hello everyone, my name is David, and I am a biochemistry expert here at X-Star Concepts. As you know, the stability of biological macromolecules is very important and needed for further reliable studies, whether it's structural characterization or the formulation of biomolecules. To save time, researchers use high-quantity methods to test new buffer conditions. Today, I will show you how easy it is to monitor the reaction of proteins to buffer conditions, and we will be using the dynamic light scattering scan of a 96-well plates with the SpectraLight 600. Since DLS is a first principle method, it comes with several advantages. Data collection is label-free, standard-free, and non-invasive. All the system needs is a small amount of sample per well, and there's no need for prior sample preparation before data collection. Exceptionally easy handling makes measuring, sample preparation, and data collection very easy and time efficient. Today's task is to find a formulation for this 83 kilodalton protein. We'll use a common screening method using this pH screen, monitoring the reaction at the molecular level. We'll mix the sample in its original buffer with twice the volume of the new buffer. The reaction will be measured by DLS. The preparation of the plate is simple and quick. We'll add the sample under the protection of paraffin oil. We'll first add a small amount of oil. The plate is now ready for loading. Once the plate is inserted, we can start our sample reaction analysis. We are now on the Autopilot tab. First, we select our loaded wells and select Drop Search, which automatically centers drops. The position will be used for DLS measurements. For visual data, we can take an image of each well. A live view allows us to check the progress of the data collection at any time. The DLS scan takes 10 seconds per well. Signal strength, sample homogeneity, and size distribution are displayed. In the meanwhile, we collected some data about the sample's reaction to the new buffer conditions. The best condition can be identified easily, and the stability can be quantified. Let's take a look at our data management view. Here we see size distribution data plots arranged according to the plate coordinates. The data is presented in thumbnail format to provide a quick overview. In order to inspect our results, we have a choice of several plot types that show different aspects of the sample's reaction. For example, overall size statistics or time-dependent plots. For visual inspection of the sample reaction, we can also look at the images with the center drops. Often, the response to new buffer conditions will cause a drastic reaction of the protein resulting in precipitation. These wells can be seen at a glance or zoomed in for a more detailed view. Such wells can then be deselected and skipped in our next DLS run. However, we kept all wells selected in this experiment and included them in our sample reaction examination. DLS measurements are possible even in such wells due to automated laser intensity adjustment and the positioning of DLS. What characterizes an improved formulation? As you can see, sample reactions to our applied buffer conditions are quite different. If we're lucky, we may have improved solubility compared to our original buffer conditions. We can easily check this. A good formulation is indicated by a specific size distribution signature. This size signature can be found in well B6. This buffer condition is well suited for our target protein, signified by three values: the absolute size, the polydispersity index, and the cumulin fit. In contrast, our original buffer condition in well E1 is worse in all three parameters, as denoted by much higher values, but it also becomes visually apparent when we overlay both plots for comparison. The improvement of the condition is obvious in this case. However, we may want to get quick access to the best conditions of this run with its 48 wells. We can do this by auto-scoring our results. An autoscore function allows samples to be automatically categorized according to specific criteria. Since we have an 83 kilodalton protein, we expect a size of around 1 to 10 nanometers. The polydispersity index value for a monodispersed sample is less than 20%. When using the autoscore function, samples that meet the criteria are summarized in a result table. The data selection can now be refined and a user score can be applied. Scoring our DLS data allows us to focus our activities on the wells with relevant data. We can move between them and skip the less interesting conditions. The user score allows us to select them all at once. Next, we could compare, export, or run autopilot tasks with these wells. DLS revealed the reaction of our sample to the new buffer conditions. Boundary dispersity, absolute size, and size stability are key indicators of sample identity and reliable formulation. Changes can be easily detected and analyzed without further sample usage or pipetting, even over longer time frames. Such long-term stability is the most important criterion for a successful formulation, meaning that the stability parameters are maintained over a certain period of time. We can automatically repeat scans to analyze long-term stability. In the current experiment, we repeated the scans periodically with a 3-day interval. A list of scans is shown in each plot variant and represented by thumbnails. This also provides a quick understanding of the progression of the sample. A user-defined scan selection can be used for statistics or plot calculations. They can be combined or compared, and the selection of scans can be saved. A comparison of the first and the last scan of well B6 shows no changes and so confirms the success of the new formulation. You may have noticed that the overall size statistics are showcased by two plots. On the right, the size distribution is weighted by mass, meaning how many milligrams of a sample are in what state. This can help to assess the quality of a formulation. On the left side is the scattered light weighted distribution. This provides maximum sensitivity for larger particles, even if their total mass contribution to the sample is negligible. Summarizing our results in a report is the final step of our analysis. To focus on the data that is most relevant to the experiment, the layout and content of the report can be configured. The report configuration option is easy to use and allows you to summarize only the most relevant data and background information in the report. The report view mode allows us to see all the selected figures and graphs at a glance and also acts as an export preview, which condition improved our formulation can be listed as well. The composition of the new buffer can be imported from the screen datasheet, usually provided by the screen manufacturers. The screen composition is displayed in the sample datasheet and can be included in the report. The exported report shows the configured layout. The export format can be a view-only PDF file or an editable document. Well, that's it for today. We hope you've enjoyed our presentation on formulation by monitoring sample reactions. We have used less than 24 microliters in this approach. If you want to learn more, you can check out our website. Until next time.